Hello everyone. In this video, we're going to be working some examples from the previous video. So just looking at the form y equals ab to the x and saying some properties of that. So let's start with our very first one. We're going to be finding the y-intercept, the growth or decay factor, the growth or decay rate, and then we're also going to find the domain and range. So let's start with problem number 1. And the very first number that I see here, that's going to be your a value. And the a value is just going to be the initial value or the y-intercept. So the y-intercept of this one is going to be y equals 1. Okay, sorry, not 1. I don't know why I wrote 1. Y equals 3. There we go. Okay, so it's just that first number that's on front. I guess that's why I wrote a 1. So let's move on to the next thing, the growth or decay factor. Remember that a factor is something that's in parentheses. That's one way you can think about it. So the growth or decay factor is going to be 1.2 because that's what's inside parentheses. Since it is greater than 1, that is going to be a growth. So we should probably write this up top. Growth is b greater than 1 and decay is b less than 1. Okay, so this is going to be growth. So we're going to write growth factor. Okay, and that's just going to be the number inside parentheses. So it's going to be 1.2. That's what it's going to be multiplying by each time. So whatever the initial number is, you're going to multiply by 1.2, then you're going to multiply by 1.2 again, and so on and so forth. Okay, and then we are going to look at the growth or decay rate. So the growth or decay rate, we are going to have to solve in this formula right here. So we have b, which is 1.2, equals 1 plus r, because we're looking at a growth. So if we're going to solve for r here, the only thing keeping us from having r by itself is this 1. So I'm just going to subtract 1 from both sides. We're going to get 0.2 equals r. But like we sort of talked about earlier, this is as a decimal. So we are going to need to convert it to a percentage by moving the decimal to the right 2. So moving it to the right 2, we're going to get 20%. So that is going to be our growth rate. Okay, the last thing that we're going to do is the domain and range. So let's go look in Desmos and type these guys in and see what our domain and range are. Okay, so here's our function, and if you notice, this thing is going, it's actually not going below the y-axis right here. That's the first thing that I noticed. And then it's just getting exponentially large over here, hence exponential. It looks like it stops about right here on the x-axis, but it actually doesn't. It keeps going forever. And you can see that by just typing in some values. So if I try like 1,000 up in the x, it will still give me a number. It's a huge number because that's multiplying by 1.2 1,000 times. Whenever you type in 10,000, it says undefined, but that actually does exist. It just is so large that Desmos can't even say what it is. So the x values can go on for negative infinity. They can also go on for positive infinity, even though the numbers get extremely large. So the domain here is going to be from negative infinity to positive infinity. Oh, I did not mean to stop sharing my screen. There we go. Okay, so it's going to be from negative infinity to positive infinity. Okay, so then the last thing that we need to do is the range. And like I said up here, the y equals k, so that number that you're adding on the end is going to be your horizontal asymptote, and that's going to be in your range. So let's look at this graph again. And as I said earlier, it's not going below the y-axis. So if you scroll this way, you can see it's going like really, really, really close. And it looks like it's touching it. But if you zoom in, if we zoom in on this, you can see that it's like super, super, super close, but it's like, nah, I'm not going to touch that. So it is getting really, really, really close to the y-axis, but it's not touching it. And the value that the y-axis is y equals 0. Or sorry, the x-axis. I don't know why I was saying y-axis. X-axis. So the x-axis is y equals 0, and that is what this is going to be approaching. And you can also see that it's supposed to be the number that's added on the end. And notice that the number that's added on the end is just plus 0. So that's another way that you can check that you're using the right number there. So this is going to be 0, and the function is starting as close as possible to 0, and then it's going up forever. So this is going to be from 0 to infinity, but since you can't be 0, we're going to put a parentheses around 0. I keep stopping sharing my screen. Okay. Here we go. All right, so the range here is going to be from 0 to positive infinity. Okay, so let's try some more examples. All right, trying example number 2. We're going to start with the y-intercept, and that's just going to be the first number that we see there. So that is going to be y equals negative 1/2. Then we're going to move on to the growth or decay factor. Since this is less than 1, this is going to be a decay factor. So it's going to be 0.83. Then we're going to move on to the growth rate. Or sorry, not growth rate, we're looking at the decay rate. And we're going to find this by solving 0.83 equals 1 minus r. So a little bit different than the equation that we're working before, because now we're working with decay. I'm first going to start by subtracting 1 from both sides, because that's one of the things that it's getting in our way. So we're going to get 0.17 equals negative r, and then we are going to have to, you get negative 0.17, and now we're going to have to divide by a negative number because that r is negative. So dividing by negative 1, we're going to get that r equals 0.17, and as a percentage, we're going to move the decimal to the right too, and we're going to get this is 17%. So our decay rate is 17%. All right, now let's look at the domain and range. And one thing that I will go ahead and tell you about all exponential functions is that their domain is the same. So the domain is going to be negative infinity to positive infinity. And then the range, we're just going to be using the number that's added on the end. Notice there's no number added on the end here, so we are going to be using 0 somewhere in there. So let's just type it in and see what this function looks like. Okay, and I'm just going to change some of the numbers. Oh. Okay, so there's our function, and you can see that this one actually does exist in negative infinity, and then it is approaching 0, just like we said that it would, because that's what's being added on the end. So since this is approaching 0, but it's approaching from negative infinity, and it's not existing in positive infinity, this is going to be from negative infinity to 0. All right, so negative infinity to 0. And it can't equal 0 because remember, it's just going to get really, really close, and then it's going to be like, nah, I'm not touching that. Okay, so let's try this last example, and then we'll move on to a real world example here. Okay, so problem number 3, the y-intercept is going to be the number that's out in the front. Since there is no number out in the front, a lot of people like to say that the y-intercept is 0. But the y-intercept here is not actually 0, and we can look in Desmos just to double check. All right, 0.03 to the power of x. Okay, and here is our function, and if you look at the y-intercept is actually 1. And it makes sense because if you put 0 on the front, the function just goes away and becomes a straight line at 0. So the number that's really out in the front is positive 1. So our y-intercept is going to be positive 1. Then we're going to look at our growth factor or decay factor. This is less than 1, so this is going to be a decay factor. And this is going to be 0.03. Then we're going to look at the decay rate, which is going to be, it's actually the same thing as just switching these two values right here. So r is equal to 1 minus b. So 1 minus 0.03, which means that r is equal to 0.97. And then we're just going to convert this to a percentage. So moving this to the right too, this is going to give us 97%. Okay, then we're going to look at the domain, and remember that the domain is going to be the same for all of these, so it's going to be negative infinity to positive infinity. And then the range, we are going to be using that number that's added on the end. Notice there's not a number added on the end, so we're going to be using 0 again for the range. Okay, we're going to be using 0, but let's go look and see where this function exists. And you can see that this function exists in positive infinity. It's going straight up right here. So since it exists in positive infinity, this is going to be from 0 to positive infinity. So I was going from the lowest to the highest there. Okay, 0 to positive infinity. Okay, we're going to look at one last problem here, and this is an application. So we're looking at the value of a phone over time that is given by this equation here. So the very first thing that we're going to look at is the y-intercept, or the initial value, and let's just call it the initial value in this case. Okay, since we do have this plus 100 on the end, that is actually going to affect our initial value. So whatever the number was out in the front, we're actually going to have to add 100 to it to get our y-intercept, or our initial value. So this 600 is going to have to be added to 100 to get our initial value of 700. Okay, now let's look at our growth or decay rate. And if you buy a phone, it's not going to increase in value over time. It's going to decrease in value because after you buy something, it's not new anymore, so then the value is taken away. So this is going to be a decay factor. And the decay factor is going to be 0.75. Then we're going to look at the decay rate. So this is the percentage at which it is decreasing the whole time. So we are going to do r equals 1 minus 0.75. Remember, we said that we could do that trick up in this problem up here. So 1 minus 0.75 is going to give us 0.25. We're going to move the decimal to the right too, and we're going to get to this percentage of 25%. Okay, and then we are going to look at the domain and range now. And I'm going to put this in parentheses here. We're looking at a practical domain. So what that means is that time can't be negative. So whenever we're looking at these values, even though on the graph it looks like this. Even though on the graph it looks like this, it is actually going to, it says that it can go in negative values over here. So you see it's like negative 0.48, and it is going all the way in negative values, and the negative values are going to keep decreasing there. So you can see negative 3.8, negative 3.9, negative 4. It's saying negative 4 time units, and negative time actually doesn't make any sense. So we're only going to start at the positive time, which is 0, and then we're going to go to positive infinity. So let's just make a note of this, that it would be negative infinity to positive infinity, but practically, so in the real world, we're looking at starting at time 0, and you can be 0, and then going to infinity in time. So how long is it going to last? Forever. Okay, and then the range, we are going to be using this number on the end, so that plus 100 is going to be important. So let's go look and see how we're going to use it. And you can see that this function is coming from 700, which is the starting value at 0. Then it's decreasing, and then it's leveling off here at 100. And of course, it looks like it's touching 100, but it's actually not. It's getting really, really close to it. So if I zoomed in over here, eventually you would be able to see that. And let's just keep going. Oh, Desmos is not going far enough in. Okay, let's see. Let's go a little bit further back. Okay, so let's come back over here. And if you zoom in, you will see that these lines are not actually touching. Even though they're so close that Desmos says that they are touching, they're actually not. So let's see if it will cooperate with us this time. And you still can't really see it. So this is sort of an unfortunate example, but that's okay. Just trust me that it is never touching that 100. That is an asymptote. So if you type in 100, well, it's a y value, so you can't really tell. But it is getting really, really close to 100, but it's just never touching it. So you can kind of see that happening here. Okay, so our range is going to be from 100 up until positive infinity, because after that it's going up and not down. So it's going to be from 100, and it can't touch 100, remember, so it's going to be parentheses there, and then going up towards positive infinity. I hope that you all enjoyed this video. Please let me know if you have any questions, and I hope that you have a great rest of your day. Goodbye.